Hello and welcome to this continued series about HTML5 gaming. I've started with talking about HTML5 as a game dev part of the industry, as well as a tool pipeline, some of the major game engines you can choose from. In a recent video, I looked at the different ways that you can get set up and started with PixiJS, which is one of the game engines out there. And ultimately, I created a project template. In this video, we're going to look at that project template, which is representing a starting point you might want to use for a PixiJS project. And I'm going to talk specifically about unit testing within that framework. My name's Sam. I'm a Unity game dev with over 20 years experience. The last decade or so focused in Unity shipping for PC, console, and mobile. I haven't done much in-browser work other than way back when I did tons of Flash gaming that was deployed to the browser. But in the last decade or so, haven't really touched it, and I'm looking to break back in as HTML5 is becoming a more powerful and compelling option given TypeScript for the game dev experience and Web GPU for the end user experience. In my work history, I've shipped titles like I mentioned, some of them listed here, as well as created game dev curriculum and taught game dev and mentored in professional teams as well as at schools. Now I'm new to HTML5, but bringing a lot of my skills and leveraging what I know from other platforms, and everything I'm going to have centralized at this link. So if you've enjoyed one of my videos or came across an article and you land at this link here, it's going to link to everything else. So it's a nice place for a home base to learn other tips, articles, and to see videos like this one. I'm going to show in the code some of the unit testing you can do from web dev platforms, and I'm going to start with some inspiration. So we all know that feeling when we start out with a new project where the code base is non-existent, or perhaps you've got a couple starter classes. It's like sky's the limit. You imagine no wrong can be done in this project compared to the other ones. Slowly you start building a spaghetti ball of all the different code without much of a foundation or an architecture or any automation to really help you along the way. And that code base grows and grows into a point where adding that 101st feature is breaking old stuff. Now, when I think about best practices as a concept, I've got a couple different thoughts here that I wanted to mention. First, thinking of it as an investment. Every decision we make, be it technology, process, or people, can be viewed as a form of investment. Investments come with a cost, and we trust that they'll pay off. So when learning something like unit testing, if this topic is new to you, I know that there's some growing pains. I know that it seems like it's going to be extra steps that are getting in the way of what you really want to be working on, but consider it an investment. Dig around in it, play with it, and I'm sure you're going to see that there's a good payoff for you. Another perspective I always think around best practices is the humanity of technology. So any fool can write code that a computer can understand. Good programmers write code that humans can understand. I think recognizing that you yourself are going to be looking at your code base forever, and your teammates, as other people involved in the project, need to be able to communicate, understand, and contribute to that code base too. So getting the human element in there is really important. And being able to create a good quality of life for those devs is vital. And lastly, in this case, there's discipline involved with best practices, including unit testing. So this quote here, "I'm not a great programmer, I'm just a good programmer with great habits." I think building, especially in the beginning of your career, these great habits and building a foundation of technology around you, like automation, which I mention automation, I'm talking about being able to do continuous integration and continuous development, CI/CD workflows, things that are going to be able to make your code base more bulletproof and your workflow more easy to use. Let's talk a little bit about the 80-20 rule and the cost of making software. So many developers feel like work is all about adding new features. I know when I sit down to a hobby project, I'm excited about thinking of the end game result. Let's say it's a game jam I'm working on, and there's 10 things that the player needs to do, and I just think I'm adding those 10 things and then my job is done. But unfortunately, focusing there is counterproductive. What we know from research is that 80% of our life is about maintaining a code base. It's not all day that we add new features. We like to think that, but really when we sit down to a week of work, there is going to be some adding of new features, but the majority of it, especially when you spread it over the lifetime of working on a project, is maintaining existing code base. Now, not all of that is bug fixing, but that's a big part of it. So when you start to shift your mentality to new features is a small part of the job, you start to open your mind to, well, if as I'm adding that 20%, I do it with best practices in mind, it's going to pay huge dividends. It's going to have that investment that I mentioned over the 80% and increase the quality of the product as well as the quality of life for those on the project. And quite famously, the earlier you catch a bug in the development process, the cheaper it is. So according to this little chart here, which is just a nice launching point for a philosophy on this, if you imagine catching the bug in a conversation with a coworker, hey, I'm about to add this new feature and I think I should do it this way. If you and your coworker decide together, oh, you know what? There's a problem with that idea. We should do this instead. That is a cheap change to make. If you didn't have that conversation or didn't catch that so early and you don't catch it until maybe integration testing or much worse for you and your team, if you don't catch it until you introduce this feature to end users, the time it takes for the end user to see it, to report it, for your customer service to catch it, for it to get into your bug tracking system, for it to come down to you as a next task to do, it's going to be, in this case, 30 times more expensive. So again, when we look at that 80-20 rule and we get that most of our life is maintaining code, and then we reflect that earlier catching these bugs is really, really powerful. Again, these best practices are going to help you maintain your code base to increase the automation and the testing you can do around it. I also recommend catching these bugs early and often. There's different workflows you can do for that. And a policy that I love is fix all user-facing bugs before adding new features. So let's look at the PixiJS project template that I made. In an earlier video, I covered it in more depth, but let's just look at the unit testing possibilities that are included in the template. All right, so from the repo linked below, I've forked it, downloaded it, and got it set up here. It's all ready to go. If you were just walking in, you could do npm install. That's going to bring in all the dependencies. You only need to do that once in the lifetime of the template. So if you've already done that, you're good. Then you can build the project with npm run build. That's going to convert your development code into something that is now playable. And then we're going to run a dev server so that I can enjoy that experience. So let's do that. That's going to be npm run and start. And this is all on the README file for the repo itself. And we could do the start. Now I've got a second option here that is called start with test. And again, all these commands are on the README. Now, if I run that, it's going to do two things. It's going to run the project, and then it's going to watch for any changes in the project and rebuild the project. It's also going to watch for any changes in the tests and rerun the tests. So let's look at what we've got going on here. It is running, and I'm going to open it up. Okay. Then I'm going to use F12 to just open up our dev windows here. So now we've got a nice environment. We have our game running. It's a very simple game, just a spinning piece of art. And then we've got our different ways to interact with that. So one of the things that flower artwork does is set its scale. So if I was to change that to be 0.5, I'm just going to save and tab back to the browser. And when I tab back to the browser, it reruns, rebuilds, and re-exports. I don't have to run those command lines again. And you can see how interesting that is to have a workflow that's so quick. Now imagine that for the non-production code that we've got as well, which is the unit tests. So let's look at the unit tests. So each time that I make that change, in addition to rebuilding to the screen as we just saw, also here in the console, it's rerunning any unit tests that you have in your project. Now, you don't need to have unit tests. Many teams would never make a unit test in their life, but I'm going to show you what I think is the beauty of it. And I'm going to do that by making a brand new class. I'll copy from something existing. We'll do a very simple and classic example of unit testing. If this is a review for you, you'd be familiar with it. We'll make a simple calculator, add a method or two to do some addition, subtraction, or something like that, and then watch the unit testing as we go. So I'm going to start by duplicating a couple files here. I'm going to take in our library, there's a templates folder and a template class. And this template class exists as a possible starting point for any class that you would create in TypeScript. You can use it as a best practice for some light commenting, the ordering from the top to the bottom. There may be some other industry standards that you can refer to. This was inspired both by my personal style and then finding a style guide here on GitHub. There's a link there. So we'll take that and we'll copy it and we'll create a new class. I'll call it the calculator. Then I will open up my calculator and just give it a name. And I'm going to get rid of some stuff here, leaving just our add method. You can see as I'm typing there that there's some stuff happening in the terminal. That's because every time I save, it's automatically rerunning all the tests. It's a bit of overkill, but we're going to enjoy that overkill in a second. So we're going to go down here to our tests, and we'll take our template class test, and we'll duplicate that as well. And I will call this, by good convention, calculator test. Great, so I've got a nice environment set up here. To review, I've got my calculator test, which is a copy and paste from a template, and I've got my calculator class, which is a copy and paste as well. The unit testing framework that I've chosen to use here is called Jest, and if you have other ones you like as well, please let me know. I used Mocha quite a bit doing Web3 work in the JavaScript world, but this one seemed to be quite cool and powerful. So there's some setup you can do here if you want some stuff to happen before and after every test. The one thing that I do is before each test, I'll create a brand new instance of the calculator class. Now, let's take a step back and think about this. One of the ways that you can do development inside of your game and debug your existing code is write production code in your game and then play the game. And then wait for the compiler to tell you there's a problem, or wait for the console to log out an error at the running game. And then when you have an issue, you would fix it and replay the game, potentially having many different interactions to get back to that point of the game where the error occurred. And then if it doesn't happen again, once or twice, you think you're done. Compare that, that's still a viable solution. That's called playtesting. Compare that to something we do with unit testing, which is we have this calculator test class that exists not for end users' enjoyment, but it exists only to consume, utilize, and prove out functionality in your production code. So in this example we're doing here, calculator represents something for real for use inside the game. And calculator test is a temporary framework that's just going to call lots of functionality and see how it works. Okay, let's create our first test here. So the exact look and feel depends on the framework you've chosen, but here inside TypeScript using Jest, it looks like this. We've got the test that something has a certain result in a certain situation, and then I like to follow the paradigm of arrange, act, and assert. First, we do any setup we need, that's the arrange part. Then we do the one action that we're actually testing, perhaps a method, and then we assert or we guarantee the expected result as is. And if the expected result is not there, it's going to give us an error. So let's just do an example here. I'm going to let expected, which is a number, equal to 10. Then I'm going to let result equal our calculator. There's already an add method in the existing one, so we'll just do add 5 and 5. And we're assuming that the result, there's a nice language you can use here, is the to be operator. So we're going to expect that the result to be better. So we're going to expect that the result is the expected. And we can see down here, all of our tests are passing. What if we change this? What if we had it be 3 plus 5? Let's run that. And we've got a failing test here because the something something is something. Let's give that a much better name here. We would say, well, I would expect when we call add, result is 10 when 5 and 5. So if we give that a good name here and I run again, we're still going to be getting a failing test, but we've got this nice output here. We're adding where the result is 10 when 5 and is 5. But we look down here and we're getting a different result. Now that's actually because I mistyped here. And let's run that one again. There we go. Now we've got a passing test. Now the more tests that you have across your code base, what you're ensuring against is what if one day the actual production code changes? So let's look at our production code. Here we have this add method, which because it's such a simple operation, it's quite easy to take two numbers and put them together. But what if by accident it was changed to subtraction? Now I've just changed the production code, and then over here we're going to see, oh, there's an error. When we're adding, we're expecting the result to be 10 when we pass in 5 and 5, but we're actually getting back 0. So that clues you in that there might be a problem or a change. The problem could be in the test, that it's inefficient or inaccurate, or in the production code in this case. So we would come back in and we would make a change here, and then we would save, and we're going to see the result. So you can start to see a bit of the power of something like this. Now let's employ a second workflow. Instead of the production code existing and then we make a test, let's do the opposite. Let's make the test first. So we're going to copy and paste this method. And I'm going to say subtract. The result is 3 when you have 10 and 7. So I'm saying the result should be 3. There's no subtract yet, but I'm going to make one. And I'll put 10 and 7. So the paradigm for test-driven development is you make the test first. Then you do just enough effort to make the code compile. Right now it's not going to compile because subtract doesn't exist. So let's go over and make our method for subtraction. And the point is to do just enough so that it compiles. So let's run that. Now our code compiles, but our test fails. Now obviously it's failing because the implementation is so weak here. But let's look at this again just to see. So we're assuming that the result is 3 when we're passing in 10 and 7. Here's 10 and 7. Okay, so I think the test looks pretty standard. We could even do more tests on top of this if we wanted to. But the next logical step is to make this test pass with properly implemented production code. So let's go over here and let's say this is A minus B. And I'm just going to do that. Now, if we weren't using testing, you would probably be coding just enough so that your code compiles and you would go play the game. And then you would reach the point of the game where this particular method here is actually being utilized. And then you would judge as a player would, can I tell that this particular value is happening correctly, or this methodology? Now, in some kinds, it's obvious that the code you just wrote is working bulletproof, right? You can see that the character moves left and now spacebar helps him jump. So if spacebar didn't work, you wouldn't see him jump, right? Sometimes it's obvious, but more often than not, it is not obvious that it's working in all cases, right? So it's so cheap to add these that you can add a bunch of them. Now, we don't necessarily just have to test certain combinations like this. You can also go in and make tests that repeat a series of them. You could like test all the values from -10 to 100, and it would run this test 150 times every time you do the test. So you can do that as well. Let's do this one more time just to get a little more feel, and then we'll probably be ending the example here. So this time I'm going to do the functionality first. Let's call it multiply. And let's say that we did an honest mistake here. Instead of A times B, I'm doing A times A, right? Then we step over here. We're going to make our test. And we're going to test our multiply, multiply. And I would say the result should be 25 when we pass in 5 and 5. And then we pass in 5, and then we pass in 5, and then 25, right? And I also want to mention that this assert statement, there's lots of stuff. You don't necessarily have to check that it is this. You can say that it's not null, is null, isn't this value, is this value as we're using, greater than, less than. There's lots of different combinations you can use there, but we're just using this one quite simply. So here we are running again, and we're saying that, I have to call multiply, of course. So there we go. We're going to run that. Now let's look at our tests here. For the sake of demo, I purposely implemented it incorrectly. But look, all of our tests are passing. Now think for a second, why is that, right? It's because while the code is implemented incorrectly, I happened to choose some test values that didn't demonstrate that and really test it rigorously. So designing your tests well so that they test just one thing, in this case, the multiply, and then also use a certain combination of scenarios that really demonstrate production code's readiness. So I'm going to copy and paste this. I'll leave that one as it is and come down here and say, well, what about 4 and 4? Well, what should that be? That should be 16. Okay, so I'll test that. 4 and 4. All right, like that. 16. I'll run that again. Now, again, remember, I know that I've purposely made the code wrong, but it's not happening again. Now, it's because I'm passing in the same parameter. In this particular case, when I pass 4 and 4, it doesn't show that there's an error here. So let's change this again. I'll make it 2 and 4, and of course that should be 8. So we'll update our code there, and then we'll run it. Now, this sentence that begins it, multiply, comma, result is 8, that's really just human readable. There's not actually anything happening within that sentence that affects the code, but it does make it nice and readable here. So when we hit this error here, and it says, oh, well, when we test the multiply, we're expecting that the result is 8 when we pass in 2 and 4. And that sentence makes sense. And then we look at the test. Well, the test seems to mimic the sentence. So it just helps you as a new person to the code base. Maybe you just double check, oh, is this actually what's happening here? Okay, it is. Then you'd go into the production code and you'd go, there's something wrong here. It's this one, and I can do this. In the moment I save, it's rerunning over there. You can imagine in a mature test having hundreds and hundreds of tests. You don't always have to run them all the time. In fact, there's some command line options I could do here that would say only rerun the failed tests, at least right now. That way you'd get quicker results. But ultimately, whenever you're doing real testing, you always want to test all of them all the time, right? So we've seen how cool that is and how nice that is to get set up. Now, not only would you maybe do purposeful testing now and again, or test-driven development, as I've just shown here, where I coded the test first, then I made the production code, then I checked the test. That's test-driven development. I love doing that. There's different flavors and different situations where some of these might make more sense than others. But the last thing that I want to mention here is that you don't just want the developers to do this sometimes, right? You also want to fold this testing into what is called CI/CD. So imagine the following scenario. Whether I've added tests or I haven't added tests, I do my production code. Then every time I commit to the Git repo where all of our team works together and there's a pull request, at that moment, the person reviewing the code could manually run the tests and say, oh, before I bother looking at this code, let me run the tests. Or they might actually pull the branch and run the game and test it. So that's play testing and automated testing, right? But you might want this to happen automatically even without that code reviewers running the test themselves. So you could have that every time a commit is done, automatically run all the tests. And if any test fails, you email the appropriate people and tell them, hey, this build has this error. Or email the developer who did the commit and tell them, hey, fix it. Or don't permit the commit to happen or the pull request to be complete if there's an error found. So there's ways you can introduce this. Now, it's certainly possible that you can have all your tests pass and the project still have some problems. This is talking about things like code coverage and also the narrow window in which these unit tests actually work, right? In this code base for here, for example, we haven't tested all the methods. We haven't tested all permutations of all values. So there's an art and a science here to choosing which tests you would do and in which order and how much of your code base to cover with tests, right? So I think that's it for this part of looking at the code testing, and also we see how elegant and nice this development environment is. In summary, super cool to see unit tests working in this particular development area. I would say that this isn't necessarily a PixiJS workflow. It's an HTML5 gaming workflow, or it could even apply to non-games, but since we're game devs, this is what we care about. So if you chose perhaps Phaser, you could still apply the same workflow, including unit tests. There's lots more stuff that we could do the tighter that the unit testing is integrated to the framework. Maybe being able to test unique aspects of sprites or interactivity where your tests are able to mimic mouse clicks and things like that. But we've got a great start here, and I hope it just gives you a little taste of what's possible. And I've really found it, as I've been playing with this, just how friendly that hot reload is to see the end gameplay as I'm manipulating code, and also to have those automated tests run every time I save a file. It's super nice. If I compare this to Godot and Unity, in those cases you either need to manually run the tests by clicking every once in a while, or you can, of course, incorporate it into CI/CD, which I mentioned, which is a nice backup. So that's it. I've covered a bit of best practices. I'll also put a link below to my general best practices that apply to Unity and Godot, much more so than HTML5. But I loved checking this out here, and I'm available for remote contract hire for Unity stuff, Godot stuff, Unity dots stuff as well. I've gotten into that last year in HTML5 as well. I'm very, very new, but I'm enjoying what I'm learning so far, and look forward to creating more content like this. Thanks.